So today we're going to try our first actively learned lesson. I'm going to ask you for some feedback at the end of the week just to kind of let me know what your thoughts are. My goal is to try to make this better and better every week. I'm learning right along with you, and I'm going to try some different tools and just see what works best. I want to try to make our lessons as close to school as possible, because it sounds like this is going to be the only way we are learning this year. So this lesson is just going to be on our 4 representations of exponential functions. My goal for you is by the end of the chapter, keep that in mind, to be able to go in between each of these representations at any time. So last week we worked on just this one right here, table to equation, equation to table. This week we're going to work on the remainder. Okay, and that's what this lesson is about. You're going to be prompted to answer questions along the way, and the video will actually stop. And then at the very end, you're going to have to submit something in Schoology for your end of the lesson. Okay, so let's get started. So our first thing we're going to do is we're going to look at equations and go to situations. And I know you're thinking, well, this looks like a situation already. There's a big paragraph, but it's just explaining some background information about this equation right here. It's essentially the piece that we really need to be concerned about is that Y is the number of employees from this Expo Grow technology company. And X represents the number of years since the company was founded or started. So we want to be able to look at that equation and understand what that equation is telling us. So just a reminder, and I'm going to use some color here to kind of help you, that 3 is that initial value or that starting value. The 4 is the common ratio or the multiplier in this situation because it's exponential. So this equation is telling us that 3 people founded this or started the company, and that the number of people joining the company quadruples every year or is multiplied by 4 every year. So that's what that equation is telling us. So that's what you're going to do for the next couple of equations, and there will be some background information there for you, and then you need to do what I just did over here, which is tell what is this equation telling us? Okay, so here's the first one. Again, we're looking for initial value and common ratio. We've got to be able to describe what they're telling us in this situation. So go ahead and read over this and then answer what you think this situation is all about. So you should have found that in this situation, the baseball tournament started with 400 teams, and that the number of teams was decreasing by half every single round. So it's one of those single elimination tournaments. Next situation looks like this. What do you think this is all about? So you should have found here that there were 285 cell phone subscribers in 1985. And in 1985, I was not one of those. I did not have a cell phone when I was your age. And that this multiplier is telling us that it's increasing by 75% every single year since 1985. And that I believe for sure. Okay, let's go on to this next situation. What do you think is going on here? So here we started with $2,400. And this is what's happening to our money. It's getting invested and it's earning 4.9% interest every year. So it's growing by 4.9% every year. Last one. In our last situation here, or our last equation, the situation is telling us that the car's value started at $20,000 and that every year it is decreasing by 20%. That's what that 0.8 is telling us. 80% is staying, so 20% is going away. Next thing we're going to be looking at is a situation, and we're going to write an equation for it. And this can prove to be a little bit more challenging. I'm using some color in my example to just kind of help you and help see things pop, so you can kind of look for that in yours as well. So the median household income in the US increased by an average of about 0.5%. Okay, this is not 5%, this is 0.5%, so keep that in mind. Each month between 1979 and 1999. Okay, so this is increasing every month. If the median household income was $37,060 in 1979, we want to write an equation for the median household income for X months. So this right here, you'll notice this red because that's going to be in our multiplier. It's 0.5%. So we have to think about what that's going to look like as a multiplier. We want it to increase by 0.5%. So that means it has to be bigger than 1. If it's not bigger than 1, then it's going to decrease. So we want it to increase by 0.5%. Keep in mind, 0.5% as a decimal is not 0.05, and it's not 0.5 because that is 5% and 50%. We want 0.5%. So that's going to be 0.005. Okay, and if we wanted to increase, we have to put a number 1 in front of it. So that's why our multiplier in our equation is 1.005. Here's our percent that it's increasing, and we have to have that 1 there because it is increasing. We've got all of our money plus 0.5% more. And this is our starting value. That's the median household income in 1979. All right, I'm going to have you do the same thing here with this situation. Go ahead and read it and then answer the question, or type in the equation, that you're finding here in this situation. The equation you should have come up with is 294,105 times 3 to the power of x, because it's tripling, and this is how many we started with. All right, let's look at the next situation. Go ahead and read that and be ready to write the equation for that. The equation you should have written for this situation is 34 million, because that's our starting value, times 0.8 to the power of x. Is it decreasing by 20%? So that means 80% of it is staying. So our multiplier is 0.8. All right, last one. Look at my puppy. This is the puppy I'm getting. First week of June. His name is going to be Arlo. We are extremely excited. So we're getting this puppy. When Arlo was born, he was 1.2 pounds, and honestly, I have no idea if this is true at all. And his weight is increasing by 12% each week. So write an equation for what's happening with Arlo. Here's the equation that is represented by what's happening with Arlo here. 1.2 times 1.12 to the power of x, because this is our 12% increase, and this is his starting weight. All right, next is going from a table to a situation. So we're going to be looking at different tables, and you really need to pay attention to the labels of the tables. That rhymed. To help you come up with what this situation is all about. Okay, so this situation is about a computer virus at the Cloquet Middle School. This is the number of uninfected computers, so the computers that are safe, that are perfectly fine. When they started, there was 27 computers that were uninfected when they started looking at it. So that's why it is blue. The next thing we have to do is figure out, okay, well, what's happening here? What's the multiplier? We know it's decreasing, so we know our multiplier has to be less than 1. So in order to figure that out, what we need to do is we need to take our day 1, which in this case is 18, divide it by 27, and you'll notice you'll get 2/3. Okay, so that means that 1/3 of these computers are getting infected every single time, and 2/3 of them are staying uninfected. And we got to check that again with the other values, otherwise we don't know for sure if it is actually exponential. And we get 2/3 as well. So that means our multiplier is 2/3. So 2/3 are staying uninfected, and 1/3 is becoming infected. So that means our equation or our situation is that we've got 27 computers that started without the virus. And every day, the number that are uninfected decreases by 1/3 every time. Okay, so every day we're losing 1/3 of our computers. All right, so now you do the same kind of thing with this table. Pay attention to what it's saying that X and Y represent. So you should have found that on the first day there was 1 leaf budding on a tree, and that every day after that the number of leaves was doubling. So that's kind of what's happening in this situation. So let's look at the second table and try to describe the situation that's represented in this table. In this next table, we're looking at our number of prairie dogs. The zoo started with 4 prairie dogs, and the population of prairie dogs is doubling every single year. All right, situation number 3. There's one more after this one. So take a look at this one. This table is showing a situation where right away when we started this quarantine, there were about 2 fights. Brothers and sisters were having a day. And as the days increase, we're noticing that it is multiplying by 5 every time. If you look at before quarantine, it looks like there was pretty much nothing going on as far as fighting. That's probably because they were never together. All right, last situation, or last table, sorry, to come up with what is this situation representing? Or what is this table representing? In this table, you should have noticed that it did not start at 0, so you have to think about, okay, what would April 20th look like? What would times 0 look like? And you'll notice that it's multiplying by 3 every time, so you have to divide by 3 to go backwards and find that 0th term. 3 divided by 3 is 1. So on April 20th, there was 1 frog chirping at night, and every night after that, it is tripling. And that's what the table is telling us. Next thing, we want to be able to look at a graph and go to an equation from the graph. This can be a little bit challenging. So I'm going to give you some things that are going to help you kind of see what's happening. And I want you to just explore. And if you don't get it right away, it's okay. It's just fine. So you're going to click on this. You're going to go to this Desmos tool here, and I'll have a link that'll pop up for you. And you're going to use some sliders. There's an A slider and a B slider, and you're going to move it around, and you're going to have to notice some things as you're sliding those sliders, and the equations and the graphs are changing. So the first thing you're going to do is you're going to click into this Desmos tool off to the side here, and you are going to write down the exponential equation of the curve you see on the screen when you first click in. So go ahead and do that first. So when you first click in, you should have seen the equation y equals 3 times 2 to the power of x. And we're going to kind of relate all the other equations that you end up writing down and looking at compared to this one. So you can just kind of see, is changing that a value, how does that change the graph? And changing the b value, how does that change the graph? So if you didn't get this one right from the get-go, it's okay. Just change it to that now. So next step. You are going to take slider A and you're going to change it to 6. Do not change slider B at all. So B is going to stay at 2. Okay, if it wasn't 2 before, just change it to 2 now. All right, then you're going to take this equation, y equals 3 times 2 to the power of x, and you're going to type it in down below. We're going to type in x our equation. Just click down below in a blank space and go ahead and type in that equation. Okay, and then I want graphs and see, what are you noticing? What are some differences between these 2 graphs? And answer that question. So the 2 equations you took a look at on this last screen in Desmos, you should have looked at these 2 equations right here. And what you should have noticed is that the only thing that really changed is the fact that it got shifted up. So that y equals 3 times 2 to the power of x, cross that y-axis at 3 and went up from there, doubling. And the other one started at 6 and went up from there, doubling. So that's really the only difference between those 2. Okay, next thing, change slider A back to 3 And now move slider B to 1.3. And I want you to look at how are those two graphs different. The two graphs that you should have just compared were these two equations right here, this one with the slider and this one already typed in. And you should have noticed that this second graph using the slider is less steep. It's kind of slanted out a little bit more because it's only multiplying by 1.3 every time. This one is going to be steeper, shoot up a little bit quicker because it's multiplying by 2 every time. So that's kind of that pattern you should have noticed there. So now in step 4, now change slider B to 0.6. Okay, so you're going to change this value right here on your slider to 0.6 and compare those two graphs. So when you're looking at these two graphs, you'll notice, or I'm hoping you noticed, that these two graphs start at the same value, just like the other ones did. They started or crossed at the y-axis at the same place, but their multipliers are different. And this one is going up from left to right, and this one is actually going down from left to right because this is decreasing. So this is a decay situation because your multiplier is less than 1. So it's going to go down, 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 down as time goes on. All right, so the whole goal in this for you guys is to kind of see the difference between A and B and how you can find them in the graph. Okay, so if you haven't figured that out yet, you may want to play around a little bit more. Here's one more step, and then you should be feeling at least somewhat comfortable with what you're noticing about A and B on the graphs. And if not, please make sure you're reaching out, okay? All right, so go ahead and change slider B to 2 and change slider A to 0.5 and take a look at this graph compared to that one. Two graphs that you just compared, you should have noticed that their steepness was the same because their multiplier was the same, but actually their y-intercept or their starting value was different. This one should have been lower on the y-axis at 1/2, and this one was starting at 3. So again, our goal is to figure out how can you find A and B from an exponential equation. So I'm hoping that this kind of helps you. You're going to have to, on the next portion of this, come up with something to share about that. Before you do that, the first thing I want you to do is take a look. I'm going to have to move myself so you can see a little better. There's a bunch of graphs over here. We just did some exploring. What we're going to do is we are going to match these with the appropriate letter. Sorry, I had to change this so you could see it a little bit bigger. I can't change my screen while I'm recording. So you can see A, B, C, D, and E graph. I want you to match it with the correct numbered. So graph A, which lettered equation does it go with? And you can go ahead and take the time to answer that multiple choice question now. These are the answers you should have come up with. A matches with this equation, starting value of 1, multiplying by 2. B matches with equation number 2. This graph starts at 4 and multiplies by 1.5 every time. C is starting at 4 and multiplying by 2, so that means it has to be this equation right here. D starts at 1/2 and multiplies by 2 every time. And so that means that D has to go with 3. And our last one, E, is 1 because it's starting at 6 and 1/2 times 4 gives us 6. There we have it. So last thing here, we are going to take a look at these things again, okay? Sorry, losing my wording. We're going to look at A in our equation. So if you're looking at a graph, how can you find A in an exponential equation from the graph? So looking at the graph, where are you going to find it? Answer that question now. You should be finding it on the y-axis. That's your starting value. Finally, B in your exponential equation. Where can you find that in a graph? Go ahead and answer that question now. I thought I'd switch back to this screen to just kind of help you if you're struggling with where B can be found on the graph. You really need at least 2 points in order to figure out what your B is. You need to look at one point to the next. What is happening to that output? So from the first point to, or from 0 point to the 1 point, what is happening to that output? It's being multiplied by 2, so that multiplier is 2 in this situation. Okay, and that would work on any of these graphs. I'm hoping that helps. All right, last thing here. We are going to take a look at, I'm going to change my screen so we can just see one page. Last thing, you need to take a screenshot of this and you need to add arrows where you feel comfortable. I'm not going to necessarily grade this based on how many arrows you have. I want you to just be able to tell me, where are you feeling comfortable? Do you feel comfortable going from a table to an equation and an equation to a table? Then make a double arrow going both directions. Okay, graph to equation, equation to graph. Do you feel comfortable going both ways? Then make an arrow pointing both ways. Okay, put in as many arrows as you feel like you're comfortable with. Once you've got those arrows, then I want you to write a sentence explaining how to find the A and B values in each of those representations you drew arrows to. So from table to equation, where do you find in the table the A value and the B value? Okay, equation to situation or situation to equation, where do you find that A value and B value? Okay, just a sentence for each. You're going to take a screenshot of this, like I said, and make sure you have that all filled out. And then you're going to add your sentences. And this will all be actually submitted in Schoology in the assignment that comes after this. All right. Hope this all worked out okay for everyone. Again, I'm going to ask for some feedback on, I know it's kind of long, but you can pause and come back to it whenever you want to, just so you know. All right. Hope it went well. Thanks. Bye.